When dealing with refracting surfaces, such as a lens, we learned that object space is on the left of the lens, and image space is on the right of the lens, meaning that all real objects are going to be left of that interface, and all real images are going to be to the right of that interface. And if an object happens to be located on the right of the interface, then that means that it must be a virtual object. And similarly, if an image is located left of the interface, then it must be a virtual image. When we have a reflecting surface, now the light is only ever going to be on the left side of that reflecting surface. And so instead of object space and image space, we now say that we have real space located to the left of the surface and virtual space located on the right. And so now all real objects and real images are located on the left of the surface. And then virtual objects and images are located on the right of the surface. And so you can see that if light never travels to the right side of the reflecting surface, then if an object or an image is located on the right of the surface, it must be virtual. So for a reflecting surface, a real object is always located to the left of the surface, and diverging light that's incident on a reflecting surface will always indicate a real object. A virtual object would be located to the right of the surface. An incident light that is converging is going to represent a virtual object. A real image is again going to be located left of your surface. So emerging light, reflected light that is converging is representative of a real image. And a virtual object is going to be on the right side of your reflecting surface. And so diverging light this way is going to be representative of a virtual image. So just like with our refracting surfaces, an object is always represented by incident light, and an image is always represented by emerging, or in this case, reflected light.